Welcome back. This is Mike from Digital Offensive, and you're watching my path to OSCP. Today is day 72 out of my 90-day labs. Time is wrapping up. I have 18 days left in the labs. I have a 0-day off day in between my final lab day and my actual exam. Taking the exam scheduled for March 21st. Lab expires on March 19th. I currently have 4 boxes left in the lab: Observer, Pi, Slave, and Master. Left in the public network. I have gotten several boxes in the IT network. Haven't touched the dev network yet, and still in search for the admin flag for the admin network. With that being out of the way, that's my update of where I'm at currently in OSCP and my studying. I wanted to go through some tech stuff in this video and give some help to those who may be struggling. Over the last few days, I kind of hit a rut after my day, I think it was day 65 video. I only had a few boxes left, and I really sat there struggling for the last few days trying to get through the next set of boxes to try to wrap up all the public and kind of get figure out where I'm going after I get the public done. So if you remember my last video, I had two last goals to really do, other than pass the OSCP, of course. But lab-wise, I have 2 goals left. And the first goal was to complete the public network, get all the machines compromised in the public network. Second goal left was to get into the, at least find the admin flag, if not get into an admin machine. With time wrapping up, I'm getting close, but I'm not there yet. So some of the things or struggles I had over the last few days was around client-side attacks, and getting through them, as well as some privilege escalation and properly grabbing passwords off machines. So I want to kind of go through a couple of items that I found very helpful to myself and may be helpful to you guys as well as you're doing this type of studying, if you're doing this in the real world, or if you're doing this like in Hack the Box or something. So the first thing is identifying client-side attacks, right? There's numerous ways to look at identifying, but some of the key areas that I found over the last few days is, 1, look at the logs. Post enumeration is key in the OSCP. Once you're done, the machine may or may not store goodies that may or may not help you get into other machines. And that may or may not part is very frustrating, I gotta say, because you don't know what you're really looking for. You may check areas that you think are common and you may not find anything and you may move on. So some of the things I would suggest, and this is what happened to me. I kind of got through all these machines, and I was stuck on a machine, so I went to the forum, kind of got a clue that I needed to look for a client side. I started digging, couldn't figure out what machine it could have been. And then I talked to a friend of mine, they're like, hey, here's another hint, check this out. And I started going back through all my notes, and then finally I was like, oh crap, how did I miss this? I took a picture of this, knowing that I wanted to come back to this, but I didn't come back to it. So with that information, I started digging deeper. So checking logs of machine. So once you're in your post enumeration phase, is that machine a web server? Is there applications running on that machine that store logs that other machines may connect to? In this scenario right here, you can see on this machine that when I went to the web server directory, I checked out the access logs and the error logs. In this case, this is the access log. You can see that this IP address was connecting and pulling these type of files. So I thought that was kind of interesting that that machine was connected to me. And right here is kind of like key. It's basically going to the root URL of that web server, and it's getting 200 response. So it's getting a successful connection, where these other ones, like the favorite icon, you see that error out a lot on many different sites. But looking at that, I was like, huh, that's weird that another lab machine would be connecting to another lab machine. Like usually you'll see tons of clients, as in the OSCP people, or you'll see actual real, the OSCP students trying to connect to the boxes. But you don't always see communication between another lab machine and the lab machine you're on. So that kind of throws up a red flag to start digging at that and seeing what it's doing. And as you watch the log, every few minutes you see that same connection come through. So it really starts making you think, is there something there I should be looking at? So looking through the logs is one of the key ways. Another idea is look at netstat. Netstat-an, OB, depending on whatever version of the operating system you're on, it has a slew of different flags. On a Windows machine where you have admin, The OB I really like a lot because basically it's going to show you the names of the services and the connections to those services, what's running those services. So you can basically drill down to what is the vulnerable service, not just a port. And then you can look for oddities in the connections. If you see a constant connection from one machine to a mail port on that server, you may believe that that machine may be pulling down attachments or emails, or if you see an FTP server, same thing. So looking at the logs and looking at the traffic, along with looking at the network traffic, also you want to be looking at possible TCP dumps, Wireshark captures. A lot of the machines in the OSCP on Hack the Box, they're older machines, so you can get portable versions of Wireshark. So basically you go out to wireshark.org and you can download their portable versions. It's simple to install. The older ones work on the older operating systems and doesn't require internet connection to do the full update. Basically, it's like a 30, 40 meg file. You copy that over through whatever means you want, install that, and you can start running your captures and looking through them. Most Linux boxes have TCP dump on the box. If it does have TCP dump, look at using Sniff if it's on the box too. I think it's called Sniff or Sniffer. Can be on some of the boxes. And it's not just OSCP boxes or Hack the Box boxes. This is in general to anything out there. So you may be able to, once you compromise one machine, you may be able to use that machine to start sniffing the traffic of the general network. And then the third thing for client-side detection, as far as like OSP, Hack the Box, and just basic information goes, is simplistic clues, right? Admins are lazy. Developers get lazy at times. So a lot of stuff, especially in the OSCP and the Hack the Box, look for like clues on websites. Like, dear XXX, this site is still working on. How about you visit XXX and leave your browser open to get updates? So basically it's telling you that this user needs to go to this website, and basically by leaving the browser open, they'll keep getting refreshed. So that tells me that there's some type of client-side attack going on there, that browser is grabbing something. And basically, can I intercept that or modify what they're grabbing? If I can modify what they're grabbing, then I can possibly compromise them. So that's another option there. So there's three options for simplicity and client-side detections that you can look for as you go through Hack the Box, OSP, any other type of CTFs out there, as well as using this in your real life as a tester. The next section I want to cover here is around window hashes. This is something I struggled with the first time through the OSCP, and I really thought I had it down pat this time. And as I started going back through my notes to try to get into other machines and looking for missing clues to compromise the few remaining boxes, I realized several things. One, I realized, I don't know if I was exhausted when I thought I was dumping the hashes, or I didn't dump the hashes on some machines. So I had to go back and redump hashes. Two, you want to use more than one tool. If you're using Meterpreter throughout the OSCP, that's fine and dandy. Just remember, when you get to the final exam, you can only use it once. Meterpreter is going to give you a different output than you're going to get from FGDump or WC.exe. Each one has its pros and each one has its cons. Whatever one you want to use, make sure you use more than one. So hash dump, very simple. It'll dump out the hashes. You can copy and paste those hashes in a file and have John the Ripper try to crack them. FGDump.exe, this will usually dump out a file to the local machine if it's successful, and that file is usually called the local loopback address.pwdump. And then you can more that file, see the hashes in there, copy them over, and try to crack them. The final one is wc.exe. Now this one has two things you can use this for. The first thing with wc.exe is you can run it just wc.exe and it's going to dump out the hashes similar to fgdump and hashdump. The one good thing about this is you can also run wc.exe space -w, which is going to dump the clear text passwords to your screen. So if that clear text password is kind of complex, but it's in memory or somewhere where it can grab it, it'll dump it to your screen, then you're not cracking it. This is very useful, especially for complex passwords that will take either forever to crack or will not crack if you're able to use this. This has been very helpful actually on several boxes I've done so far. And it has actually been a savior for moving forward on other boxes. So something to definitely keep in mind there. All these tools, I basically keep fgdump, wc.exe in my Apache web directory. I usually use certutil, PowerShell, wget, curl, a slew of different methods to basically be able to download my tools from my host to my victims to be able to execute them as I go through each box. And something you should definitely look at, it's like in one of the earlier labs, there's a whole section on file transfers throughout your exploitation as you're going through each box. Now, a lot of people skip over that because documentation in that section is not required. It's definitely a section you definitely want to go through because it's only going to help you later if you don't use interpreter through everything. Now, if you're using interpreter through everything, you have your upload and download, which makes life 100 times easier, but it's not going to help you long term when you get to the exam or when you're in the real world and you can't use an interpreter. The next thing I want to cover, you guys, is delivering your payloads through a client. Actually, in this case, just really around using client-side attacks that are basically using web, right? So basically, they're making a request to a website, and how do you go about injecting yourself into that to basically deliver a malicious payload? There's other types of client-side attacks and how to deliver your payloads, and you'll basically experience several of them as you go through the OSCP, hack the box, and things like that, and of course, in the real world. The easiest thing I found with the web delivery is when I detect a client or a victim accessing the other victim through a web request that I already routed, I can now modify that web page to either redirect them to myself or to just basically backdoor that page they're requesting to deliver a payload. So in a recent attempt, I see client XYZ connecting to the server. I'm root on this server. They're making a request for a certain web page. I do some initial enumeration based on my logs. I see that they're vulnerable to XYZ based on their user agents and stuff like that. So do a little research. And basically what I do here is I basically echo into that file my malicious string here. So basically this is a meta redirect. So when you visit the web page, it's going to instantly, right, 0 seconds, redirect you to my URL. And at my URL, I have my index.html, my whatever my payload is that I want to deliver. And I'm echoing that file, this command, into the local file, index.php, index.html, whatever the local file is on that machine. So basically what happens here is when the client connects to that host that I've compromised, it's going to automatically redirect their web request over to my web server, and my web server is going to deliver them the malicious payload. The other server is not going to know the difference because basically they got redirected. They're following the 302 message they're getting by the meta redirect, and they're now grabbing my payload and executing my payload. That works great. Now, the other one, too, is instead of using a redirect and wiping out the whole page, you can add at the bottom of the page or insert iframe into a page. And basically, when they visit the page, the iframe loads the malicious payload as well, and the malicious payload gets executed. I found that the meta redirect worked better. It was a little bit cleaner than it was using the iframe, especially if they have any type of cross-site request forgery enabled or anything like that that's going to basically block your ability to carry out the iframe. By basically overriding the whole page with a redirect, it seemed to work out much better. Some other tips there for client-side and web attacks here is WordPress sites. If you go to your General and Settings tab, under Settings, you can actually define the WordPress website to go to. So you can set up a malicious WordPress site on your side and basically edit the address to point to your IP / your WordPress location. And what will happen is basically any request to that WordPress site will now get redirected over to your WordPress site. And you can deliver your payload that way as well. The final one is using beef, and basically using beef hooks to intercept those web requests. And basically, same thing with the beef hook is kind of like those echo statements above. Basically, you're injecting your malicious code into an existing web page that when the URL, when the client connects to that page, it's basically executing that script, causing that beef hook to connect back to the beef server, which will allow you then to carry out different levels of attacks based on the browser and everything else. I did not find beef very useful so far, but it's definitely a great tool to use and have it in your arsenal. One of the next things I see a lot happen on Linksbox for privileged escalations is understanding the output. Everyone tells you to look at Got Milk. They tell you a slew of different other Linux enumeration blogs. You can use enum.sh, Linux perp checker.py, but unless you know what they're outputting, it's useless to you, right? You're going to get a list that's several pages long. You're not going to understand any of the stuff in there. You're looking for that red herring that you know that you can quickly tie back to a known exploit. But do you really understand what you're seeing in those logs and what you can do with that data? Two of my favorite Suid priv escalation checks or commands for privilege escalation checks is these two right here. So find permissions with group Suid. And basically what this does is it's going to run and find all Suid files, or Suid group is SGID, however you want to pronounce it. But basically any file that has that Suid flag checked, and that will run as the group and not the user who started. And the key here is not the user who started it. You're a low privileged user that does not have access. If this Suid file has permissions to run as a elevated group, and you're able to abuse that Suid file to carry out a different task, that's going to run as that elevated group and not you, which means it's going to be able to carry out that task at hand. The other one basically is the same, almost the same here, but this is going to do as the owner and not the user. So basically, let's say you have a file that's owned by root, a Suid file that's owned by root, and you have the ability to execute that file, even though you're not in the Suid users group or anything else, because it's Suid. When you execute that file, it's going to run as root. There are several commands out there that if it has this flag, you're able to manipulate it to carry out additional escalation tasks, either reading a file, giving yourself a shell, so on and so forth. So these two are definitely two very good commands to run, and really good to understand the output from them. And if you don't understand the output from them, the resulting commands that come back, run those commands through the man pages and understand what the options are of those commands. One thing I found was really good with Hack the Box is Hack the Box has a lot of the escalation points in Hack the Box are not exploitable. You can't go out to exploit DB and drop an exploit and exploit it. Many of them are misconfigurations, either Suid or some other way, using a flag of an application or something along those paths to basically escalate to root. The Hack the Box will really get you thinking in that manner. It's moving you away from the thought process of, oh, I'm going to drop dirty cow, boom, I'm root. No, it's basically understanding what you're seeing and figure out how to escalate your path from there. I can tell you so far in the last 72 days being back in the lab, I've not used dirty cow once in the lab, and I have almost all the lab machines compromised. So that should tell you something, right? First, it tells you don't need to be using dirty cow on every machine because, one, it leaves the machine in an unstable state usually, and two, it's not usually the intended path to root. With that being said, have I used other kernel exploits? Yes, I have. Usually I result to the kernel exploit if I've exhausted all other ways and I can find out the way to do it. And believe me, it drives me bonkers if I can't find another way to do it, because that means I'm missing something. I'm missing a learning opportunity that I can better myself to understand a better way to exploit that machine without resulting to a kernel side exploit. Now, maybe kernel side exploit is the way to do it. Unfortunately, in OSCP, you'll never know until maybe one day they retire that box and they decide to release that information. I don't know. I haven't seen that done yet, so I'm not holding my breath that it will ever occur. One of the final things I want to go through in this video is I see a lot of people complaining about why my XYZ exploit doesn't work, that they basically created the MSF Venom payload, they insert it in there, and it no longer works. But the previous payload worked. A lot of times they're trying to replace a bind shell, reverse shell, things like that. There is one famous box out there that if you go back a year or two, when you used MS Venom, it would generate a properly sized payload that worked instantly in that exploit. And no one asked questions because basically you updated it, ran it, boom, you got your shell. Coming back into the lab this time and going back through it, that exploit no longer worked for me. And it took me a while to figure out why. And as I read through the exploit code, I realized it says payload needs to be XYZ size. When I generated my payload, I noticed my payload was too big. So, what can you do if your payload's too big? There's different flags in MS Venom that allow you to shrink down your payload size. So you can basically tell it to use the smallest size available, which is helpful. And if it's too small, you can also add more additional knobs to your payload to make it bigger. So with those two options, you can basically adjust your payload sizes to fit within that the window that you have, the buffer space that you can use. Now, if you don't understand what I'm talking about and you're trying to manually edit payloads and do things like that, go back to the buffer overflow section, look at the buffer overflow as you're building it. And actually, maybe that is a bad example because the buffer that you're using in that lab is basically you can put almost anything in that thing. It's such a large window that anything can fit. But maybe if you look at like right to lib attacks, basically where you have a small window and basically how you can load the rest of your data into that window, similar to like interpreter stagers. So basically like using a interpreter shell where basically I'll download X bytes and then set up a listener and then basically download the rest of that data through that listener to get the full interpreter shell. Something to check out there. So payload size is definitely key. I know I've gone through this data pretty fast and I can't give you a lot of detail around stuff because these are actually active attacks that we've been using in the labs and hack the box stuff. But hopefully you can put two and two together and this will give you a little bit more information about where to go and start thinking through your post-enumeration process about what to look at. If you're just jumping on the box and you're grabbing your screenshots for your proof, your user, your host, you're missing a wealth of information. With that being said, that's all I have for today. If you have any comments, questions, post them below. I'd love to get some feedback. I recently hit 1,000 subscribers, so thank you all for your support. Continue subscribing, continue sharing this out to everyone. I love to share my information with you guys, and hopefully these videos are helpful to you. I get a lot of great feedback from people saying, hey, this is very helpful. I'm about to do my OSCP. Dude, that's awesome. I love hearing from you. If you want to stay in touch, hit me up on Twitter and LinkedIn. Unfortunately, I don't really take friend requests on Facebook just because I share a lot of my family stuff on. I click that bell at the top to be notified when new videos come out. And thank you all again. I look forward to seeing you.